Welcome to the another class of engineering mechanics for preparation GLET 2020. This is my fourth class. Some of my students have messaged me that to discuss with chapter wise, so I do the same. In my first three problems, the systems deposited in my first three problems are in equilibrium, and as such the lines of action of all the external forces must be concurrent, that is meet. The solution is then obtained by drawing the Freebody diagram for the system and the corresponding force polygon. So let's focus on the first problem. A body of weight of 10 Newton is suspended by a string of 10 centimeter long and is held at a point 6 centimeter from the vertical line, passing through the point of suspension by a horizontal force. The horizontal force is, there are four options. So what is the problem say? A body of weight 10 Newton. So this is the main diagram. If you simplify the diagram, you can draw a free body diagram from this main diagram. So a body of weight of 10 Newton, that is the 10 Newton, is suspended by a string 10 centimeter long. That is the string 10 centimeter long and is held at a point 6 centimeter from the vertical line. That is the vertical line, and 6 centimeter from this vertical line, passing through the point of suspension by a horizontal force. So this is the horizontal force. We have to find out the value of this horizontal force. So this is the free body diagram, and from this free body diagram we can find out the value of the BC, that is the BC. Okay, so let's assume that the tension of the string T and the length of the string is 10 centimeter, that is the string, and the 6 centimeter difference between the vertical line, that is the 6 centimeter. And so BC, the value of the BC from Pythagoras law, with the help of Pythagoras law, length BC equal to root over 10 square minus 6 square, that is 8 centimeter. Okay, next, from this problem we can write that F by AB, that is F by AB equal to W by BC, that is W. So this is the W, you can assume this is W, so W by BC. So F by AB equal to W by BC, F equal to W into AB by BC. The value of the W is 10 Newton, the value of AB is 6, the value of AB is 6, and the value of BC is 8 centimeter, so 7.5 Newton. So the answer is 7.5 Newton. The second problem, a circular roller of weight W hangs by a tie rod and rests against a smooth vertical wall. The tension in the tie rod AB will be. that is the main diagram. So a circular roller, that is the circular roller of weight W, that is the W weight, hangs by a tie rod, this is the tie rod, and rests against a smooth vertical wall, this is the smooth vertical wall. The tension in the tie rod AB. So we have to find out the value of the tension of the tie rod for this portion. Okay, so there are 4 options. So from this diagram, you have to draw a free body diagram. So that is the W from this diagram. This is the W, and this is the tension side. This is the AB portion, and this is the resultant. This is the resultant. From this free body diagram, we can easily write that T sine theta equal to W. T sine theta equal to W, or T equal to W by sine theta. From this calculation, from this equation, you can easily write that since sine theta is less than, this is the equation, T equal to W by sine theta. So for this condition, sine theta should be less than 1, and the tension, the value of the T should be greater than W. So from this option, the answer will be greater than W, that is B. Next problem. In the hoisting mechanism deposited in the line AB is free to turn in a vertical plane through points A and B. It is fastened by BC to a point that lies on the wall vertically above point A for a load of 1000 Newton supported by cable at B. The force along AB would be. These are the 4 options. This is the main diagram. So from this main diagram, in this hoisting mechanism deposited in the line AB, that is AB, is free to turn in a vertical plane through points A and B, that is A and B. It is fastened by BC. It is fastened by BC to a point that lies on the wall vertically. This is the vertical line above point A. Above point A. Okay. For a load of 1000 Newton. This is the 1000 Newton load and supported by cable at B. The force along AB. So you have to find out the force along AB, this value. Okay, so from this main diagram, you can simplify the main diagram as a free body diagram. This is the free body diagram. Okay, so from this free body diagram, let's focus on the problem. FAB by AB. What is FAB? That is the FAB. So FAB by AB, this is the AB and this is FAB. FAB by AB equal to W, this is the W and this is the W by AC and this is AC. So FAB by AB equal to W by AC. So FAB equal to W into AB by AC. So W, the value of the W is 1000 Newton, that is 1000 into AB. What is the value of AB? What is the value of AB? This is the AB and the value of the AB is 4 meter. So this is 4 and the AC, the value of AC is 5 meter. So in place of AC, this is 5. So 1000 into 4 by 5, so 800 Newton. So the answer should be 8000 Newton. For my next 3 problem, it deals with Lamy's theorem. So You all know about the Lamy's theorem. It said that if three forces acting on a particle keep it in equilibrium, then each force is proportional to the sine of the angle between the other two forces. So my next three problem regarding Lamy's theorem. So let's focus on the fifth problem. A sphere of weight 400 Newton rests in a group formed by two planes OA and OB, and these planes are inclined at 30 degree and 60 degree respectively with the horizontal as shown in figure. This is the figure. The reaction on plane OB will be about. So these are the four options. Students, this is the fifth problem. I missed the fourth problem. Okay, after discussing the fifth problem, I'll return on the fourth problem. Okay, so let's focus on the fifth problem. Okay, so this is the main diagram. This is the main diagram. So the sphere of weight 400 Newton rests in a group formed by two planes OA and OB, and these planes are inclined at 30 degree, that is in 30 degree and 60 degree respectively with the horizontal. So this is the main diagram, and from this main diagram you can draw the free body diagram. So we have to find out the reaction on the plane OB. Reaction on the plane OB. I think this is the O point. So we have to find out the reaction OB. So from this diagram, this is the free body diagram. You have to simplify this diagram. This is the free body diagram. So we have to find out the reaction on the plane OB. Okay, so let's focus on the problem. This is the free body diagram. Look very carefully. Let R1 and R2 be the reactions at point P and Q respectively. So R1 is the reactions at point P, and R2 is another reactions at point Q. So from this free body diagram we can easily write that as from Lamy's theorem, W by sine 90, that is the W by sine 90, and the opposite of sine angle sine 90 equal to R1, that is the R1, and the R1, this is the R1. So at the opposite side, that is 150. So R1 by sine 150. And from this equation, you have to find out the value of R1. R1 equal to W sine 150 by sine 90, and the value will be 200 Newton. So the answer of this problem is 200 Newton. This is the fourth problem, students. I missed this problem basically. Okay, so let's focus on the fourth problem. A string 2 meter long is tied to the ends of a uniform rod that weighs 60 Newton and is 1.6 meter long. The string passes over a nail so that the rod hangs vertically. The tension in the string in Newton is. So there are four options. So a string 2 meter long. The total length of the string is 2 meter and it is tied to the ends of the uniform rod. This is the uniform rod, and this total is the one string. This is 1 meter and this is 1 meter. Okay, 60 Newton weights, 60 Newton weights, 60 Newton weights, and 1.6 meter long. 1.6 meter long. This is 1.6 meter. The string passes over a nail so that the rod hangs vertically. So it hangs vertically. So we have to find out the tension in the string. We have to find out the tension of the string. So from this diagram, you can draw a free body diagram as I discussed previous. So from this free body diagram, we can write that AC equal to BC equal to 1 meter, because AC equal to BC equal to 1 meter, because the total length of the string is 2 meter. That this is AC and this is BC, 1 and 1. So AC equal to BC equal to 1 meter. So from ADC triangle or from BDC triangle, CD, if you find out, if you want to calculate the value of the CD, so CD equal to root over 1 square minus 0.8 square equal to 0.6 meter. So the value of the CD will be 0.6 meter. The value of the CD will be 0.6 meter. So sine alpha equal to 0.8, sine alpha equal to 0.8 from this diagram, and cos alpha equal to 0.6. CD, cos alpha equal to 0.6. Okay, so let's focus on the problem. The three forces W, T and T. This is W, this is T, this is another T. So the three forces W, T and T are in equilibrium. So from this free body diagram, we can easily write that W sine 2 alpha equal to T sine 180 degree minus alpha. So W sine 2 alpha, the value of the sine 2 alpha, the formula of the sine 2 alpha equal to 2 sine alpha cos alpha, and the value and the formula of the sine 180 degree minus alpha equal to sine alpha. So W by 2 sine alpha cos alpha equal to T sine alpha. So from this problem, the value of the T should be 50 Newton. 50 Newton. This is the T, and T equal to W by 2 cos alpha. The value of the W is 60. 2 cos alpha, we can previous calculated the value of the cos alpha equal to 0.6. So cos alpha equal to 0.6, 2 into 0.6. So 60 by 2 into 0.6 equal to 50 Newton. So the answer should be 50 Newton. This is the last problem for today's class. An electric light fixture weighing 150 Newton hangs from a point A by two strings AB and BC as shown in figure. This is the figure. The tension in string AB would be approximately. So this is very common problem. Very common problem. So this is the electric bulb, electric light fixture weighing 150 Newton. The weight of the light was 150 Newton, hangs from a point A. This is the point A by two strings. This is the two strings. AB is the one string and the AC is the another string. Okay, so this is shown in the figure. We have to find out the tension in the string AB. Tension in the string AB. So from this main diagram, you have to draw a free body diagram. Let's look on the free body diagram for calculating all the angles. This is the free body diagram, and from the geometry of the system, the angles between the forces are as indicated. So here is the W sine 25. According to the Lamy's theorem, W by sine 75 equal to T2. This is the T2 equal to sine 150 degree. So W sine 75 equal to T2 sine 150 degree. From this problem, from this equation, the value of T2 will be 78 Newton. So the answer should be 78 Newton. So that's it from today from my side. We will again discuss with another topic in engineering mechanics for Gillette preparation 2020. Thank you all of you.